All right, let's just jump right in. We are absolutely surrounded by data, right? Just endless streams of numbers. But what if I told you that hidden inside all that noise, there are these powerful, really important stories just waiting to be told? See, the secret isn't just having the data, it's knowing how to make it speak. So today, let's become data storytellers. Okay, so our story kicks off right here, in a neighborhood in a city called Greenville. A technician went out and took 20 water samples to test for lead. And this is what they got back. Just a table of numbers. Site 1 has 11, Site 2 has 22, Site 10 has 40. I mean, looking at it like this, it's just a sea of numbers. It's a mess. It's almost impossible to spot a pattern or figure out what's really going on. And that leads us to the big, critical question. Is this just random noise, or is there a genuine health crisis buried inside this table? The stakes here are incredibly high, because when we're talking about drinking water, you really have to be sure. So what's our benchmark for safety? How do we know what's good or bad? Well, according to health standards, lead concentrations have to be less than 15 parts per billion. That number, 15, is our line in the sand. Anything at 15 ppb or above is a potential problem. Now, with this one critical number, we can finally start to make some sense of that messy table. To do that, we're going to need our first tool, the dot plot. A dot plot is just perfect for a situation like this. It takes a small, countable set of data, like our 20 water samples, and just neatly organizes it on a number line. It's the simplest, fastest way to turn all that chaos into clarity. So we take all 20 of those samples, put them on a dot plot, and boom, a story instantly becomes clearer. As you can see from the analysis, most of the sites, a full 16 out of 20, are clustered together safely at 12 ppb or less. But you can also see that one clear outlier, one single site that tested at 22 ppb, well over our safe limit. Now, the Environmental Protection Agency, the EPA, has a rule. They require action if more than 10% of samples are over the limit. So let's do the math real quick. One problem site out of 20, that's exactly 5%. So for this one neighborhood, we're actually below that 10% threshold. It looks like no immediate citywide action is needed. Case closed, right? Well, not so fast. Remember, that was just one neighborhood. The mayor of Greenville needs to see the picture for the entire city, and now we're dealing with 250 samples. Can you even imagine trying to create and read a dot plot with 250 individual dots? It would be a complete mess, just as useless as that first table. We're going to need a new tool. To handle this much bigger data set, we need to upgrade, and this is where the histogram comes in. A histogram is designed for large amounts of data. Instead of plotting every single point, it groups the data into these intervals, or bins, and then just shows you how many data points fall into each bin. It's all about seeing the frequency. And here it is. This is the histogram for all 250 sites in Greenville. Each one of these bars shows the number of sites that fall within a certain range of lead levels. You can see the tallest bar is for sites between 10 and 15 ppb. So a lot of sites are getting close to that line. But now, look at what happens to the right of that 15 ppb line. The story is very, very different now. Let's just add it up. We have 47 sites in that 15 to 20 bin and another 23 in the 20 to 25 bin. That is 70 sites in total that are at or above the 15 ppb limit. Out of 250 samples, that comes out to 28%. 28%. That is nearly 3 times the 10% action level. Now we have a public health crisis. But this is where our story takes a really interesting turn. Because the same exact tool that can be used to reveal the truth can also be used to hide it. Data visualization is an incredibly powerful thing, and it can be used for good or for not so good. So check this out. Someone named Marcel created this histogram from the exact same data and tried to claim everything was fine. How? Just look at the bins. He made them way too wide. The crucial one is that middle one, 10 to 20 ppb. Our all-important 15 ppb threshold is now just lost, swallowed up somewhere inside that huge bar. You can't see it anymore. I mean, when you put them side by side, the difference is just night and day. The correct histogram, with its carefully chosen bins, isolates and reveals the problem. Marcel's histogram, with its wide, clumsy bins, hides it in plain sight. You literally cannot tell how many sites are above 15 ppb. This is a masterclass in how to lie with data. So the plot thickens. The governor gets wind of this situation in Greenville, and now she wants a state-level view. She asks a pretty simple question. How does Greenville's problem compare to its neighboring city, Oaktown? So now our challenge is to compare two large data sets quickly and effectively. For this job, we need our third and final tool, the box-and-whisker plot, or you can just call it a box plot. This chart is an absolute genius at summarizing an entire dataset using just 5 key numbers. It's the ultimate tool for comparing different groups at a single glance. So first, here are the raw numbers, the 5 number summaries for both Greenville and Oaktown. You can see Greenville's median is 12, while Oaktown's is lower at 8. Greenville's maximum value is 22, while Oaktown's highest is 15. But the most telling number here, the one to really watch, is Greenville's third quartile, Q3, which is 16. And remember, Q3 marks the 75th percentile. When you turn those numbers into a picture, wow, it tells a starkly different story for each city. For Oaktown, every single sample is at or below that 15 ppb safe limit. The problem is basically contained. But for Greenville, the situation is alarming. That box plot shows us that the top 25% of all their sites are above the safe limit, which points to a really widespread issue. And this is the key takeaway for the governor. That single box plot tells her, in one glance, that more than 25% of all water sites sampled in Greenville are above the safe lead limit. Just like that, she knows exactly which city needs urgent investigation and action. That is the power of choosing the right way to represent your data. So, let's recap our data analyst toolkit really quickly. If you've got a small set of data and you want to see every value, use a dot plot. If you have a huge data set and need to see the frequency and distribution, use a histogram. Just be smart with your bins. And if you need to compare two large data sets head-to-head, the box plot is your absolute best friend. You know, we started with just a confusing table of numbers. From there, we went to a neighborhood assessment, then uncovered a citywide crisis, and finally made a state-level comparison. We didn't change the numbers at all. We just chose the right way to look at them. And in doing that, the data finally got to tell the story of Greenville. Which really just leaves us with one final question. You are surrounded by data every single day. Now that you have the tools to make it speak, what stories are hiding out there in plain sight, just waiting for you to uncover them?